This is Lesson 9, Solving Problems About Proportional Relationships, Activity 2, called Biking and Rain. And this is an infogap problem in which there are two problem cards. Problem card number 1, which is May and Noah riding a bicycle to a park. And problem card number 2, which is a rainstorm. So rain is falling at a certain rate. And one person, so the students are placed into pairs. One of the students gets the problem card, the other student gets the appropriate data card. So this is the data card for the biking and rain problem, and this is the data card for, this is the data card for the biking problem, and this is the data card for the rain problem. And the student is supposed to ask information about what's on the data card so that they can solve the problem. So May and Noah each leave their houses at the same time and ride their bikes to a park. And they're riding at different speeds, so who arrives at the park first? So first of all, there are two properties, once again, distance and time, and what connects those two properties is the ratio of distance to time. So distance is equal to the ratio of distance to time times the time. And remember that distance per time has a special name. It's the constant of proportionality. It has a special name called speed. And so the ratio of the two properties connects them. It's the constant of proportionality. And you usually write that as the unit rate. And that is the speed. So how far did each travel at what speed? So the data card tells you that May travels 8,000 meters at a speed of 250 meters per minute. So 8,000 meters at a speed of 250 meters per minute. And Noah travels 9,000 meters at 300 meters per minute. And the equation is written as distance equals distance per time times time, or speed times time. But you want to know the amount of time. So you can rewrite the equation as time is equal to the distance, and this is actually multiplying by the reciprocal. This is 1 over 250, which is the reciprocal of 250, and this is 1 over 300, which is the reciprocal of 300. So multiplying by the reciprocal is the same as dividing, and that makes sense. If you divide by 250, 8,000 divided by 250, every time you can take out 250 meters from 8,000 meters, that's equal to a minute. So how many times can you do that? You can do that 32 times. Or every time you can take out 300 meters from 9,000 meters, the number of times you can do that is going to be the total time. How many times can you do that? You can do that 30 times, so that's 30 minutes. So let's look at that calculation in a little bit more detail. And here's the form of the equation once again. So you multiply the distance times the reciprocal of the constant proportionality. So to get this equation, you're going to multiply the distance times the reciprocal of the constant of proportionality. So you can write y equals kx, and so that tells you that time is equal to k, and k in this case is the speed times the time. But you want to know time. So you're going to rewrite this as time is equal to the reciprocal of the constant of proportionality times the distance. And that's the same as dividing by that constant. So distance divided by this speed. So that's distance divided by that speed, or distance divided by this speed. And you can do that almost in your head. You might realize that 1,000 divided by 250 is 4. And so how many times do you have 1,000? You have that 8 times. So that's 4 times 8 equals 32 minutes. Or 900 divided by 300 is 3. And how many times do you have that 900? You have that 10 times. So 3 times 10 is equal to 30 minutes. So the person that gets there first is Noah. It takes him 30 minutes, where it takes May 32 minutes. Yeah, so Noah gets there first, takes him 30 minutes. May, it takes 2 minutes longer, takes her 32 minutes. All right, so what about the rainstorm? Same idea. So rain is falling over a certain amount of time. So the two properties are the amount of rain in centimeters. So that's written as C, and the time in hours. So that relationship, what connects them is the rate, the centimeters per hour, the time, or the amount per time. So centimeters per hour. So the total amount, centimeters, is equal to the ratio that connects centimeters to time. So notice again, I wrote the centimeters in the numerator here because you're going to end up with centimeters as the answer, and time in the denominator, because what happens to the time is that cancels out. You're left with the amount of centimeters. Now, in this case, you want to know the time, so you're going to have to rewrite this equation so that time equals, it's going to be the reciprocal of this relationship. So it's going to be time equals time over centimeters times centimeters. So you have to rewrite it as the reciprocal. So this is, first of all, I'm going to simplify this. This is 9 6/10 centimeters per 24 hours. So that comes from the data card. If you divide 9 6/10 by 24, you get 4/10 of a centimeter per hour. So now here's the 24 hours, the 9 6/10 centimeters. The other three items here, they all tell you the same thing. Or actually, they don't tell you the same thing. This one tells you the same thing, but this is just the relationship between millimeters and centimeters, and this is the relationship between minutes and hours. But if you work with just hours and centimeters, you don't have to use any of these three. All right, so centimeters is equal to the constant proportionality, which is 4/10 times the amount of time. So the amount of time, now this gets tough. You have to realize that what's the reciprocal of 4/10? It's 1 over 4/10. So 1 over 4/10 times the number of centimeters. So this gets tough, and this is where you have to practice and really think through, are you going through the correct steps? And it just takes thinking about this in context of rain falling over time. All right, so a little work here on what is the reciprocal. 1 over 4/10. The reciprocal, what's the reciprocal of 4/10? Sorry, it's 1 over 4/10. So 1 over 4/10, and 4/10 can be rewritten as 4/10. Well, 1 divided by 4/10, you can solve that, or you can rewrite that as the inverse operation of division, which is multiplication. So it's 1 times, and what's the multiplicative inverse of 4/10? It's 10/4. So 1 times 10/4, and you can simplify 10/4 to 5/2. So this is the better form to get this number in. 1 over 4/10 is the same as 5/2. So you might practice going from here, 4/10, rewriting it as the reciprocal, and simplifying it to 5/2. All right, so now I know that the time is equal to 5/2 times the amount of rain. So the amount of rain is 5 centimeters. So how much time does it take for 5 centimeters of rain to fall? It's 5/2 of that. So it's going to be a bigger number. So 5/2 of 5 is 25 halves, which is equal to 12.5. It takes 12.5 hours for 5 centimeters of rain to fall. Now, does that make sense? It took 24 hours for 9 6/10 centimeters. So 5 centimeters should be a little bit more than half of 9 6/10 centimeters, because half of 24 is 12. It's a little bit more than half, and that's true. 5 is a little bit more than half of 9 6/10. Now, another way to calculate this is, rather than use the equation, just use the reasoning that this 5 centimeters is a fraction of 9 6/10, and it's the fraction of 24 hours. So the amount of time that's going to take for 5 centimeters to fall is that fraction out of the total 9 6/10 centimeters. So 5 out of 9 6/10 centimeters times 24 will give you the amount of time that it takes for this 5 centimeters to fall. If this was 4 8/10 centimeters, that's half of 9 6/10. So 4 8/10 over 9 6/10 is 1/2. 1/2 of 24 is 12. So it's no different. This is a fraction of 24. Now it's a little bit hard to work with, but that's okay. 9 6/10 is the same as 9 3/5. And 9 3/5 is the same as 48/5. It gets tough, but just hang in there. So 9 6/10 is the same as 48/5. So that's going to be 5 divided by 48/5, or 5 times. What's the reciprocal of 48/5? Reciprocal of 48/5 is 5 48ths. So 5 times 5 48ths times 24. It's a fraction of 24. So all of this is to get this to a fraction, which is 5 times 5 divided by 48, which, by the way, is 25 divided by 48. That fraction of 24. Now, I know it's a bit tough, but just practice it. And so now you can get to this part right here. So this is 5 times 5 divided by 24. 5 times 5 divided by 48 times 24. And 24 48ths, you can rearrange this. Oh, actually, here it is. You can rearrange this to multiply the 5 times 5 is 25, and then 24 over 48 is the same as 1/2. You can factor out these 24s, 24, and this is 2 times 24 to get to 1/2. So now it's 25 divided by 2, or 1/2 of 25, and 1/2 of 25 is 12.5. You eventually get to 25 halves, which is where we were before with this 25 halves right here, when we changed this 1 over 4/10 to 5 halves. Sorry about that. A little bit tough, but it's worth trying to go through and trying to understand it. Don't give up.